So I'll just go start recording this might as well. So it's a scratch demo, and I know we've got 10 minutes before they're going to kick us out. So I like to go on Reddit, and there's a scratch subreddit, and people ask questions on there. They ask for help. There's also a place on Scratch itself, like forums, where people ask for help. And well, one person had sort of a sassy meme about people asking for help and not getting it. And he showed like a picture of a big lineup of people asking for help, and then like people offering help, no one. And so I said, I like to help people. The problem with a lot of people is they have a hard time describing their program. They take like a camera picture of their code instead of sharing the project. So if on Scratch, any project you can share, and then I can see your code. So any project that someone else can see, there's projects that are private, and there's projects that other people can see and use. And if they can use it, they can also see your code and all your assets, all your sounds, all your pictures. So it's really cool how you see something you like, you dig in and look at their code, kind of like on GitHub, right? But everything, you see everything. Okay, so after a few messages back and forth, he said he wanted to see. They said they wanted to see 100,000 clones, so 100,000 items in a game, um, and have it render somewhat quickly. So the issue is the game Scratch limits you to 300. You can't display more than 300 at once, but you can keep track of a lot in memory. So it offers you lists, and you can have lists. And so I did get something running. It does do the thinking. It says setting up, please wait. And so it does run. Now setup's complete. So these are a bunch of pants. And if I move my little cat around, I think I just use the arrows here. So if I move him around, you'll see some, sort of like he's walking, right? And he's walking by some pants. But if I go back the other way, the same pants in the same location show up. So see, there's those two on the bottom left. If I walk to the right some more, they disappear because I sort of have a range limit of how far I can show. But then the same two come back. Or if I go down, they fall off that render, and then I come back, and they're there. So there is in memory, there's 100,000 locations, and it checks if which ones are in a range close enough to your sprite, um, and then it chooses to render them or not. And I was having a hard time. I started with 10,000, and even that was running really slow. So here's the code for the cat. So the cat you press an arrow, it changes the X and Y variable by 10, and that's it. It does call this a setup complete thing to get him to have a speech bubble come up and make the other one go away. But most of the code is in this pants project. So, oh, it sets up a few variables here, and then it sets up all the pants, and it checks the pants and draws the pants. So these pink ones are functions. You can make your own block of code with a function. And so down here, it's defining what check pants is and what setup pants is. So each color refers to one of these dots on the side of a type of code block, an event, a control, an operation. Yeah, so if you see here, repeat 100,000, that is a loop. That's like a for loop. For 100,000 times, it'll run this code. And then this has an if condition and an else block. So if this is true, it'll run this code. If it's false, it'll run all the code in here. So setup basically adds 100,000 pants in random locations each time, yeah. So if I run it again, it'll be different, yeah. So it's not like a seeded thing where it'll be the same each time, but it's just random. Um, yeah, so you could use a complicated function to generate seeds and have a consistent game, similar to how I remember like Atari River Raid. It's sort of the same level every time you're going through level one, level two, level three, but it's all procedurally generated. Well, not procedurally, but generated with a calculation, so it doesn't take up a lot of space on the chip with big maps to find, right? Yeah. Okay, well, I'll help in a little bit, but it's almost time to go, so maybe it's time to pack up and we can do next time. So one thing I noticed was the to checking on which pants I should render. I checking 100,000 pants to see if they're in range was really slow. So what I did is did some optimization. So I sorted the X list, and if you look at here, we can have variables. We can have a list, pants X, and here it is, and it's sorted. So the X list is sorted, and I had to look up how to do that because I tried doing an insert sort by myself, but I missed a couple plus ones and minus ones, and it just wasn't working. So I looked at some other code, a different program language, but the algorithm's the same. So I just implemented in Scratch. So it's sorted. The Y list is not sorted, but that helped me to eliminate enough. And then I just give myself a little window I look into. So the window is the smallest one I matched with last time, minus 1,000, and then plus 2,000. And so I'm looking in a range of, I'm only looking at 3,000, 3,000 from the smallest match. So 1,000 back and 2,000 forward. Yeah. Into one list is sorted, the other one's not. It's only looking at it's only looking at 3,000 to see if it matches. Yeah. So the first time it actually runs through everything until it finds the smallest match. And so yeah, so with a little bit of optimization, um, the drawing code is not very complicated. Uh, we add we add the path we want to draw to a list, and so you're able to have lots of different sprites in memory and stuff. And